Alright, this video is going to be my first video about cell division, and really we're going to talk right now about why do cells need to divide. Now when I ask that question in class, a lot of kids will say, well, we need to divide in order to grow, or we need to divide if we get hurt, and we need to make new cells, which is all true, but what about single-celled organisms? Why do they need to divide? So we're going to talk about some common reasons for all cells, including bacteria or cells in our body, why they might need to divide. There are going to be two main reasons that cells need to divide. The first one is that in a larger cell, there's going to be more demand on the DNA. DNA is like a genetic library, and one library cannot feed sort of a really large place. Imagine, your hometown and its possible local library, and it might very well serve the needs of your town, but it couldn't serve your entire state. Similarly, the DNA doesn't get larger as the cell gets larger. And so a larger cell means more demand on the DNA, and that's going to be really hard in a cell. Number two, larger cells are going to be less efficient at moving nutrients and waste in and out of the cell. Obviously, it wants food and other things to come into the cell, waste and things to go out of the cell, and we don't want to wait to get nutrients in, or we don't want to wait to move waste out. And the rate for entering and exiting the cell is related to the cell's surface area to volume ratio. So where surface area is on the top of the fraction and volume is on the bottom of the fraction. Cells want to keep a high surface area to volume ratio. So that means a high numerator and a low denominator. High surface area, low volume. This is sort of a common question for this unit. What's the surface area to volume ratio of a cube with, for example, the side of 1 centimeter? We'll do this on the other page. If I have a cube, side of, no, that doesn't look very cubish, sorry. Side of 1 centimeter, which means all sides are 1 centimeter. Let's calculate the surface area first. So the surface area is all the area on the outside surface. We have 6 sides. Sorry. And in this case, they're all going to have the same area, which is basically 1 by 1, which is 1 centimeter squared. So we'll just use 1. So the surface area for us is going to be 6. The volume for a cube is its length times width times height. And so surface area to volume for our cube of side 1 centimeter is going to be 6. Let me go back. Okay. What about one with a side of 3 centimeters? Again, not cube, sorry, but so let's assume everything's the side of 3 centimeters. Surface area, again, we have 6 sides. And the area of one side is going to be 3 times 3, which is going to be 9. That gets us, should be about 54. Okay, volume is 3 times 3 times 3, which is 27. And so our surface area to volume for this one is 54 divided by 27, which is 2. Okay, so in increasing the size of our cube, we got a smaller surface area to volume ratio. And as we said, we want a high surface area to volume ratio. So the smaller cell will typically have a higher surface area to volume ratio. Hence, when these two things become a problem, right, we have a huge demand on the DNA, the cell's getting too big, or we're getting too big, we can't move stuff in and out of the cell because now we are decreasing our surface area to volume ratio as we increase our size. The cell will divide into two new smaller cells, which leads to an increased surface area to volume ratio, and then of course, obviously, smaller cells meaning less stress on the DNA. And of course, before dividing, we need to keep in mind everything that we've learned up until this point. Before dividing, the cell needs to make sure it has at least 2 copies of everything. And I mean everything. So obviously DNA, and we learned about that in DNA replication, but other things, including organelles, it's going to want to have at least 2 of everything.